Okay, so this is our first section of 3 sections we're going to do this year in Chapter 9. This is 9.1, Solving Right Triangles, which is simply nothing more than a review of the right triangle trigonometry you did in Integrated Math 3. So we're going to go back to your old acronym SOHCAHTOA, and we're going to do everything in degree mode. And we're going to work on being able to solve right triangles. Fun stuff, pretty straightforward, and I believe you have seen all of this before. So today's objective will be to use trigonometry to find unknown sides or angles of a right triangle. So now first, we've got to understand the notation of a right triangle. So this is right triangle ABC. And what you need to understand is how we label the sides of a triangle. All right? And the way it works is this. See this lowercase a right here? It is opposite angle A. And that's the way we label. So a side length will be the lowercase letter of the letter that represents the opposite angle. So A is opposite side A. And angle B would be opposite side B, and angle C would be opposite side C, like that. And that's how we label any triangle. So with this triangle, let's put some given information in and see if we can come up with some of the information that is not given using right triangle trigonometry. So I'm going to tell you that this acute angle A is 28 degrees. Now, with one more piece of information, I could solve this entire triangle. So how about if we say that side A is 40 and they didn't give me a unit there, so that's just 40 units. Okay, so with that, what could they ask us? All right, let's find the length of side B to 3 significant digits. Okay, so again, right triangle trigonometry, so we're going to use the acronym. What did they give us right here? Opposite and adjacent. So do you see what I'm saying right here? And remember this acronym SOHCAHTOA right here? All right. I know that the acute angle A has a measure of 28 degrees. And the A is opposite that angle. And the B is adjacent to that angle. Right? And by the way, the C is the hypotenuse of that right triangle. All right? So opposite to adjacent is one of my trig ratios. And you see the TOA right there? That is tangent is opposite to adjacent. So we're going to go tangent of 28 degrees has to equal the trig ratio of opposite, or 40, over adjacent, or the B. And now we have an equation that we can solve for B. So if I'm going to solve for B, what am I going to do? I'm going to multiply both sides by B, and then this is now B times tangent of 28 degrees, but we have to undo that multiplication by tangent of 28 degrees. So on the other side, we're still going to have that 40 in the numerator, but we're dividing by the tangent of 28. And there you go. Now let's get out our calculator, and let's make sure we are in degree mode. Throughout this chapter, we're going to use degree mode. So clear mode, and my calculator is in degree mode right now. And then I'm just going to punch out 40 divided by tangent of 28 degrees. Okay, now what are you getting? All right, I am getting 75.2 degrees. By the way, too, we are going to, that's not 75.2 degrees because that is a distance. So that's 75.2 units, and that's the 3 sig digs right there, 75.2. So that's it, right triangle trigonometry. All right, let's do another one. Okay, so now find the distance x from the base of the house. So you guys see, this is a rough sketch of, this is my house. Do you see that wall right there? And then my roof right there. So the base of the house is right here. So find the distance x from the base of the house to the foot of the ladder. So this must be a ladder on the side of my house right there. So the foot of the ladder to the base of the house, this would be my x right here. Okay, and we need that to 3 sig digs. Well, do you notice that this is, again, a perfect right triangle with an acute angle of 70 degrees. All right, and we need to find x, and we're given the hypotenuse of that right triangle is 20 feet. So you've got to think about your trig ratios again. Okay, and SOHCAHTOA right here. Now, isn't the x adjacent to the given angle? And isn't the 20 the hypotenuse? So I'm thinking the trig ratio adjacent to hypotenuse. Do you see that CAH? Cosine is adjacent to hypotenuse. So to solve for this x, I'm going to use cosine of 70 degrees equals, and my trig ratio would be adjacent, and again the x is adjacent to the acute angle of 70 degrees, and the 20 is my hypotenuse. So now let's solve for this x right here, and this is one simple step. Let's multiply both sides by 20. So x equals 20 times cosine of 70 degrees, and that is approximately, let's punch this out, and we're going to want this to 3 sig digs again. So I'm going to go clear and 20 cosine of 70 degrees, and the 3 sig digs right here, I'm 6.84. Now they didn't tell us what, oh yeah, they did, 3 sig digs right here. So this distance right here would have to be 6.84, and did they give us any units here? It's from the base of the house to the foot of the ladder. Again, there's no, oh yeah, that hypotenuse is in feet, so this x would be in feet right there. So that is 6.84 feet. That's reasonable. That must be a really big ladder though. It's reaching pretty high up that house, isn't it? Okay, good. Oh, now another question. Find the height y reached by the ladder. So again, that's a big ladder. I wonder how high this ladder is going. All right, so let's think about this one now. We want y, and I'm going to use the given information, the 20 feet. So do you guys agree that the y is opposite my acute angle and the 20 is the hypotenuse? So my trig ratio will be opposite to hypotenuse. And you see the SOH right there? Sine is opposite to hypotenuse. So I'm going to go sine of 70 degrees equals, and my trig ratio would be opposite y to hypotenuse 20. And now this is again a one-step equation. Let's just multiply both sides by 20. So y equals 20 times sine of 70 degrees. And let's punch that one out. So 20 times sine of 70 degrees is, and to 3 sig digs, I am getting 18.8 feet. 18.8, and remember our units, feet. So this ladder right here, that's a big ladder, is reaching 18.8 feet up the side of this house. Wow. Okay, how are you guys feeling? I hope you've seen all of this before. Now, find the measure of angle A. I hope you recognize that notation from geometry. The measure of angle A, and A is this acute angle right here, so we're going to find this measure to the nearest tenth of a degree. So look at what they've given us in this right triangle. The 553 meters is opposite the acute angle A, and the 100 meters is adjacent. So again, I'm thinking SOHCAHTOA and opposite to adjacent. So opposite to adjacent, SOHCAHTOA is tangent is opposite to adjacent. So I'm going to start with tangent of the acute angle A is, and what's my trig ratio here? Opposite 553 over adjacent 100. So now let's just inverse tangent to both sides to solve for that angle A. So A is approximately, so let's all get out our calculators and do this together. Inverse tangent, second tangent of 553 divided by 100. Can I just go 5.53? 5.53. And if you want to put the fraction 553 over 100, of course you can do that. All right, so let's see what this is. And now I believe in this chapter they're going to ask you to do every angle to the nearest tenth of a degree. So I'm going to call this 79.7 degrees. Let's see how we did. 79.7 degrees, look at that. And that's it. SOHCAHTOA, right triangle trigonometry. Okay, I hope this is looking very familiar to you. All right, now, oh, look at this diagram. It looks like we have an isosceles triangle, and the altitude or height of that isosceles triangle is right here. So the base, which is 4 units, has been divided to 2 units here and 2 units right there. So, and then these legs of this isosceles triangle are 8 and 8 with a base of m right there. Okay, so let's see. Find the measure of angle D, that would be that acute angle right there, the measure of angle E, this acute angle right here, and then the measure of angle F, the vertex angle of my isosceles triangle up there, to the nearest tenth of a degree. Okay, well, you notice if you have an isosceles triangle and you put the altitude of that triangle into the diagram right there, don't you have 2 congruent right triangles? Because this angle right here would have to be 90 degrees. So if I'm going to find the measure of angle D, okay, I'm going to use my right triangle trigonometry, and I note that this 2 is adjacent, and the 8 would be the hypotenuse of that right triangle. So adjacent to hypotenuse, we're going to have to use cosine. So cosine of angle D is, and my trig ratio again, cosine adjacent to hypotenuse. 2 is adjacent, and the 8 is the hypotenuse. Now you could reduce that, but we're going to use our calculator anyway here, so let's just leave it 2 over 8. And now we got to solve for the D. Okay, so angle D is approximately, so to undo this cosine, let's just do inverse cosine on both sides, and that's going to give us inverse cosine, second cosine, of 2 over 8. I just can't write that. I'm going to go 1 over 4. Okay? And to the nearest tenth, I'm getting 75.5 degrees. All right. So this is an isosceles triangle right here. So if angle D is 75.5 degrees, what do you think angle E would have to be? And you remember from geometry, aren't the base angles of an isosceles triangle congruent? So guess what? The measure of angle E would also have to be 75.5 degrees. And now we have angle F, which is the vertex angle of this triangle up here. Now, go back to geometry one more time. Do you guys remember the triangle sum theorem? Angle F. Well, what do the 3 angles of any triangle have to add up to? And I'm talking about this entire isosceles now, all right? The 3 angles have to add up to 180 degrees. So that means angle F would have to be 180 degrees minus the 2 75.5 degree angles. So I'm going to go 180 degrees minus 2 times 75.5 degrees, and 2 times 75.5 would be 151. 180 minus 151 degrees would give me 29 degrees. So the vertex angle, angle F, of this isosceles triangle is 29 degrees. Oh, good stuff. Hey, look at that. That's it. So throughout this chapter, we're going to round angle measures to the nearest tenth of a degree, like we did today, and we're going to round any length to 3 significance digits, which I think that's what we did every time today as well. And your homework will be page 335, 13 through 23 odd. Okay, and now with the longer periods too, I would like you guys to get a good start on this, and I'd love to get a start on another section today. All right, you guys have a great day.